Okay. Oh goodness, here we are. Finally, got a minute. Let's go. So let's look at how we're gonna graph this stuff. So the way I was taught and the way that I teach my students is to go like kind of like one piece at a time and never do like too much at once. So if we're looking at this function, let's just like go verbally over what this means. Um, this hello. Oh, I hate this. This plus 3 means I shift upward. So if I have a plus 3 that's not like on the inside, that means I move it up 3, just like a nice little vertical shift. This 3 changes our amplitude. And the other way that I like to think about it is that this is always where our midline is. And this is always where our, or how far min slash max from midline. Okay, so before I do anything with this shift up in here, I like to just draw sine with my amplitude and my vertical shift. So what I'm going to do is I'm actually going to change this axis a little bit. I'm going to throw up a midline up in blue so that we have a nice area where we're centered around. The next thing that I want to do, actually, let me, it's this template settings. Let's go with the grid. There we go. Maybe this will help a little bit. So I need to cover at least 4 boxes because those are going to be like my 4 points. So always we're going to start with 2 pi unless I have a period change, which I don't in this case. So 2 pi 3 pi over 2, pi over 2. We have our midline. That's going to appear at 3. Our absolute maximum is going to be 3 more than that, so that's going to be at 6. And sine, it starts in the middle and goes up. So it's going to start here. And the reason why I graph these points specifically is, like I tell my students, these are the quote-unquote fun points. Something fun happens. It's either a maximum, a minimum, or it crosses the midline. So it starts at the midline for sine, hits a maximum, crosses the midline, hits a 0, or excuse me, a minimum, not a 0, and then hits that midline back. Now, what does this plus pi over 4 mean? That means I take it and I do the opposite of whatever it says. So instead of going plus pi over 4 to the right, I go to the left. Now that on this graph is a little bit tricky, but basically we know that pi over 4 is half of pi over 2. So we're really just shifting it over, looking at my graph that I have here, half of a unit. So this peak is going to be right here. That point is going to be there. That minimum is going to be there. And that's going to be there. So what I'm going to do is I'm just going to take it and shift it over just a teeny bit. I'm going to take this over and shift it just a teeny bit. It's not perfect because obviously I'm drawing it. So what you have here is perfect. Just going over the few different pieces. Your midline's at 3. This distance is 3, which is great. And then looking at, like, it looks like there's 1, 2, 3, 4. So shifting it over pi over 4 is just shifting it over 1 block. So B was probably originally here, and you just moved over 1, which is awesome. So nothing too crazy there. These next two get a little bit more scary. So let's go ahead and do this piece by piece. So when I look at a graph and I'm trying to pull information out of it, I really want to look what's going on between 0 and 2 pi. I don't really want to consider other stuff that's just going to confuse us. And the other thing I want to do is do the easy stuff first. So I can see that I go from 6 to 2. So my total like height of this function, I know we don't normally think of that in trig, is 8. So my midline is going to appear at half of that. So my midline is going to appear at 4. So with Did I? Oh, wait, no. This is -2. That's why it's weird. And I wrote that wrong. The amplitude's 4. This is 2. I'm confusing myself. So this distance here is 4. This distance there is 4. So I know my amplitude for this function is going to be 4. I also know that I shifted up 2. So at the end, I'm going to have a +2. Now, when I look at these, I just want to see where it starts when I'm at 0. If it starts all the way up top, all the way at the bottom, or in the middle. Those are like the easiest cases. So this one, it obviously starts in the middle because I'm starting here and going down when I'm at 0, which in my mind is the start of a period. So if it starts in the middle and goes down, that's going to be sine, but more importantly, it's going to be negative. So sine starts in the middle. If it's positive, it goes up, kind of like we saw here. It started here, went up. And this one starts here and goes down, so it's negative. Now, the next piece I need to do is I basically need to see how many waves happen within 2 pi. That's the easiest way to do it. So what I'm going to do is I'm going to cut off all this other crap that I don't want to look at. And I'm just going to count how many waves happen. So normally sine has just like one little hump up top, and now we can see I have 1, 2, 3, 4, 5. And more importantly, to be really specific about it, at that point where our 2 pi ends, I need to be in the same position. So I start in the middle and I'm going down, and I end in the middle going down. So I have 5 waves. So my input value needs to increase 5 times as fast. That's how I like to think about it. So this is going to be 5x. And we could go into Desmos in a half a second and like kind of show that these are the correct solutions. Now for the trickiest one. Now this one is the trickiest because, as you can see, at my starting point, I'm not in the middle or exactly at the top of the bottom. So we're going to have a period shift, a phase shift, vertical shift, and a amplitude change. So once again, I'm going to just start with the same exact thing. I'm going to start with looking at my midline and my amplitude. So we could definitely see that this is going up 1. So when I write it, I'm going to have a +1 at the end. And I could see that this distance here and that distance there, those are both 2. So it's going to be 2 something, 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 +1. Now, here is the fun part. We need to do 2 things. One, I need to figure out if I want to use sine or cosine. Then I need to figure out how many waves I have. And then I need to figure out how much I'm off by. So, a lot of weird things going on. I have, looking here, I'm closest to cosine. So this starting point is really close to that vertical, or like the y-axis, which is normally where we start. So I'm going to choose to write this with cosine. You could write it with sine. The only thing that's going to be different is your phase shift. So how much you're moving left or right is going to change based on if you use cosine, or if you, I don't know, want to use like negative sine because it starts there. It's just going to be shifted different. Now, I need to see how many waves happen in 2 pi distance. So let's be very careful here. Where I start, I'm starting here and I'm going up. So I need to like find how many times that happens within 2 pi. So it happens once going up, twice going up, 3 times going up, and that's the completion there. So I know that the waves are happening 3 times as fast. What just happened? And once again, we're going to take a peek in Desmos and see that. Now, moving left and right is a little bit tricky. So we just need to see how I want to move. And now that I see that I graphed this up, I did it kind of a more complicated way. So what I originally have is minus 3 pi over 4, which means I essentially took the original function that looked like this and moved it all the way over there. So I'm shifting it 3 pi over 4 to the right. Oh, wait, no, I know why I did that. Sorry. So what I looked at here with this point here is I know it crosses like exactly through this plane, that line right there. And because of your axes here, I know that this is 3 pi. Oh my goodness, man. I know that this is 3 pi over 4. So I moved my starting point for cosine, which is up top. I moved it to the right 3 pi over 4. The reason I didn't utilize this, or like how much I shifted from there to there, is because I have no clue how far over that is. I just don't. In the same way that I don't know exactly where that is, and I don't know exactly where that is. But I could figure out exactly where this is. So, the other thing you could have done is say like, oh, okay, if I want to write it as something else, I know exactly where this crosses the middle here. So this here looks like negative sine because I start in the middle and go down. So I could have shifted negative sine over pi over 4 as well. So let's take a look at Desmos, just make sure we know what's going on. So I have the last two drawn up. So here's the first one. I want to change my step to pi, and I want to graph, see, it was pi over, nope, I want 2 pi. So this is just going to help me show what I got going on in 2 pi and kind of show those waves again. So I'm just going to show, or we could just see, if you just count the waves that happen up top, I can't point because I'm in Desmos. We have 5 waves that happen, so that's where I get that times 5 from. I shifted this one up 2 if I graph y equals 2. We can see that happens right in the middle. Looking at the second one, so I want this to be, what do I want it to be now? I want it to be 1. So we can see that happens right on in the middle. And we get the same exact picture that you have. So truthfully, the one thing that I would suggest doing is anytime you get these questions, just bring it into Desmos and like fiddle with the numbers. It's going to sound stupid, but like looking at how you change the numbers, especially with the period and the phase shift, so moving the period, making it skinnier or fatter, making the wave skinnier or fatter, and then shifting it left and right, having you do that and like, oh, what happens if this is negative? What happens if it's positive? What happens if I do negative cosine instead of positive? Like that sort of thing. It's going to help you get like a little bit better of an understanding to be able to do this on paper, kind of like we did here and here. So let me know if you have any other questions. I know it's kind of hard because I can't like point at things. So if you do have more questions, just bring them Sunday, and either before or after Exalt, we could talk. Okay, have a good rest of your weekend. Get some time away from math. Ain't nobody want to do this all weekend.